So the first question, madam. The capacitance of an isolated sphere of radius R1 is increased by 5 times. Okay, is increased to 5 times when it is enclosed by an earthed concentric sphere of radius R2. The ratio of their radii is giving the options 4:5, 5:4, 5:1, 3:5. So try it. Everything is given. The capacitance of an isolated sphere of radius of your how much for me? R1 is increased by 5 times when it is enclosed by an earthed concentric sphere of radius of your R2. Okay. If it is only one, then C is equals to 4 pi epsilon naught into R1. Isn't it? When it is earthed, then C2 will be equal to 4 pi epsilon naught into this is R1 R2 divided by R2 minus R1. What is telling in the problem? It is enclosed by concentric and it is increased by how many times? 5 times. That means I can write this one. C2 is equals to 5 times of your C1. C2 value is how much for me? 4 pi epsilon naught into R1 R2 divided by R2 minus R1 is equals to 5 times of 4 pi epsilon naught into R1. 4 pi will get cancelled. R1 and R1 also will get cancelled. Simplifying it, we will be getting R2 divided by R2 minus R1 is equals to your 5. Clear? So R2 will be equal to 5 times of R2 minus 5 times of your R1. Got it? So I need the ratio. So if I need the ratio right now, I'll bring this one 5 times of your R1 outside and all R2 on one side right now. So it is 5 times of your R2 minus of your R2. That means it is R2 common. This will be equal to 5 minus 1. So it is 5 times of R1. What is R2? 5 minus 1 is 4. This is 5 times of your R1. So R1 divided by R2 is equal to how much for me beta? 4 divided by 5. So the ratio will be equal to how much for me? 4:5. Melissa, just going to go through it once. First one was like this. Of radius R1. Second one was right now like this. Isn't it? When it is enclosed by an earthed concentric sphere of radius of how much? R2. That means it is R2, it is your R1, and it is earth like this. So we got the formulas for both of them, C1 and C2. And the problem is telling that isolated sphere of radius R1 is increased 5 times when it is earthed by an enclosed by an earthed concentric sphere. So C2 is 5 times of C1. Just simplification will get the answer from. One more question, better. See this one. 8 capacitors. 8 capacitors. Each of capacity 2 microfarad. 2 microfarad are arranged as shown in figure. The effective capacitance is how much? The effective capacitance between A and B. Between A and B is how much? First one is 10 microfarad, 12 microfarad, 16 microfarad, and fourth one is 4 microfarad. So this is given diagram. This is one capacitor here. This is one capacitor here. And down there is one capacitor here, and there is one capacitor. Okay. This is connected to terminal A, and this is connected to terminal B. And between there is one capacitor like this. And there is one more capacitor like this. Okay. All of them are having what capacitance beta? 8 each of your 2, 2, 2. That means this is C, this is C, this is C, this is C. Everything, the capacitance is right now for me the C. So what is the effective capacitance between A and B? Anyone? These two are in which combination beta? Anyone? These two are in parallel. These two are also in parallel. When they are in parallel, it will be equal to how much for me beta? 2C. C and C, it will be your 2C. This one is also your 2C. That means if I remove the 2 and remove it by your 1 capacitance, so that will be equal to how much for me? 2C. I'll draw the diagram here, you see. The above two capacitors will be as it is. I can remove the blue one and connect this one somewhere here. So this will be equal to C and C. This will be equal to 2C. So this is 2C, this is C, and this is C. Then below one is also same thing right now here. Here it is right now C and C. This will be your 2C. And below there is one capacitor like this here. Okay. And this one is C, and this one is your C. And this is your terminal A, and this is your terminal of your B. What will mean? These two are in which combination? Series combination. When they are same, that will become how much for me? C by 2. This is also in series combination. This is also C by 2. That means ultimately we'll be getting capacitor like this. Above one is C by 2, down one is C by 2. This is 2C, this is 2C. This is the terminal of your A and terminal of your B. Now all of them are in which combination beta? Parallel combination. C effective will be equal to how much beta? C by 2 plus 2C plus 2C plus C by 2. C by 2 plus C by 2 is nothing but C. C plus 2C plus 2C. That will be equal to 5 times of C. That is equals to 5. Each is right now much for me? 2. 5 2 is a 10. So it is a 10 microfarad will be the answer. Done, beta. So, see one more question, beta. The charge Q in coulombs passing through a 10 ohm resistor. 10 ohm resistor as a function of time. As a function of time t is given by q is equals to 3t square minus 2t plus 6. The potential difference across the potential difference across the ends of resistors at a time t is equals to 5 seconds is. Shall I try to do it? Giving the options 120 volt, 240 volt, 140 volt, and 280 volt. Read the question carefully. The charge in coulombs passing through a 10 ohm resistor. There is a 10 ohm resistor like this. R is equals to 10 ohm. As a function of time t is given by, so whatever the charge is being flowing, so q is equals to 3 into t square minus 2t plus 6. The potential difference across the ends of the resistor. This is say for example A and this is say for example B. Potential differences across A and B will be equal to. So V is equals to your I into your R. So charge is given. How do you calculate I as a function of time? I is equals to dq divided by dt. That is d into this is 3t square minus 2t plus 6 divided by your dt. Now differentiate this one better. So in this one, I is equals to 3 out. Differentiation of t square is right now for me 2t minus. This is a 2. Differentiation of 6 is same. So 6t minus 2. This is your current. So at what time? At t is equals to 5 seconds. The current is I is equals to 6 into 5 minus 2. 5 6 are 30 minus 2. It will be equal to 28 ampere. So this will be equal to 28 into resistance is how much for me? R is equals to how much for me resistance? 10 ohms. 280 into 10 is nothing but 280 volt will be the answer. Got it? Fourth option. Done, madam? One more question. One more. Two identical cells. Two identical cells gave the same current. Gave the same current through an external resistance. Through an external resistance of 2 ohm regardless whether the cells are grouped in series or parallel. Okay. The internal resistance of cell is the internal resistance of cell is. First option is 1 ohm. Second option is 0.5 ohm, 1.5 ohm, 2.0. So try to do it. We have got two identical cells, gave the same current. Current is same through an external resistance of 2 ohm, regardless whether the cells are connected in series or whether the cells are being connected in your parallel relation. That means when the cells is either in series or in parallel. How do you calculate it better? When cells are in series, the current will be equal to how much? I is equals to total EMF divided by total resistance. Total resistance is right now for me how much for me? 2 plus resistance will be equal to 2 times of R. Got it? Like say when two cells are being connected like this, one positive, negative, it is connected to an external resistance of capital R. This is having internal resistance R1, R2. This one is E. This one is E. So in this one, there is a flow of a current I1. So I1 is equals to how much? But I is equals to total EMF divided by total resistance is your formula. So I1 is equals to total EMF for E plus E. Total resistance is capital R plus of your 2R. So this is your R. Now in parallel combination better. If cells are connected in parallel, one positive negative and one positive negative. And this both of them are connected to an external resistance like this. This is E, this is E, internal resistance R and R. This is your R. And from here now the current will be I2. So at that time I2 will be equal to, in parallel the EMF will be remaining same beta. So it is E divided by external resistance is capital R. Resistance are in parallel. So it will be equal to R divided by 2. Since current is same, since current is same, I can say that I1 must be equal to your I2. If I1 is equals to your I2, just equate them. So it is 2E divided by right now 2 plus of your 2R is equals to, this is your 2E divided by 4 plus of your R. 2E will get cancelled. So this will be equal to 2 plus 2R is equals to 4 plus of your R. All the R terms you can take on one side and all this one taken down. So it is 2R minus R is equals to 4 plus of your. This is plus, this will become for me minus. That is 4 minus 2, this will be 2. 2 minus R. R is equals to how much for me? 2 ohms. Got it? See this question. If the kinetic energy of a particle in motion, of a particle in motion is decreased by, is decreased by 36%. 36%. The increase in de Broglie wavelength, the increase in de Broglie wavelength of the particle is how much? So now try to do it better. The kinetic energy of the particle in motion is decreased by 36%. The increase in the de Broglie wavelength of the particle is equal to how much? Options are for me 18%, 25%, 20%, 32%. So try to do it. What is the de Broglie wavelength formula beta? Gurtunda. Lambda is equals to h divided by under root of your 2m into your kinetic energy. That means de Broglie wavelength is inversely proportional to root of your E. So lambda 1 divided by lambda 2 is equals to under root of your E2 divided by E1. Okay. And the problem is telling that if the particle of the motion is decreased by 36%, isn't it? The increase in the de Broglie wavelength will be equal to how much? If it is increased by, that means 36% decrease, remaining is 64. Initial will be equal to 100. So that will be equal to how much for me? 8 by 10. That means it is 4 by 5. So lambda 1 by lambda 2 is 4 by 5. He is asking the percentage. So lambda 2 minus lambda 1 divided by lambda 1 into your 100 is equals to 5 minus 4 divided by your 4 into your 100. That will be equal to how much for me? 5 minus 4 is 1 by 4 into your 100. That will be equal to how much for me? 35%.